Worksheet 2 on particle motion. Let's look at number 1. By the way, the one on the test is similar to this. It's not as bad with all the decimals and stuff, but it's similar in that, here's one equation and then there's 8 questions about it. So S of t, negative t cubed plus 7t squared minus 14t plus 8. Question A, find the instantaneous velocity and velocity when time is 2. Well, we know that the velocity is the s dt, so we'll take the derivative, negative 3t squared plus 14t minus 14. Double check that when you do that, because most everything else comes from that equation, so if you make a silly mistake on a derivative, then the whole rest of the problem is going to be messed up. So do a quick double check to make sure that looks right. V of 2, plug in 2, and we could leave that as an answer, but I suspect we may need it later, so I'm going to actually find out what it is. So that's 2. Units, this was all in meters and seconds, so meters per second for velocity units. Part B, find the acceleration of the particle. So acceleration is derivative of velocity, negative 6t plus 14. And at 2 seconds, that would be negative 12 plus 14 is 2 meters per second squared. All right, I think we're through with the easy questions on this. Very straightforward questions. Now we get a little bit more complicated. When is the particle at rest? Well, rest means v equals 0. So we'll set the velocity equation equal to 0. And we can play around with it and see if it will factor, but it won't. So I'm going to go to the calculator and put in, again, I've got other equations up here for other stuff, but there's the velocity equation. Again, double check to make sure it's right. Graph it. I'm on kind of a weird window, but I see all that I need to see because I really just want to know where it's equal to 0. So I could have used the quadratic formula here, but I'm going to use Calc 0. Left bound, right bound, guess. So one answer is 1.451. I'm wondering if I should write down a few more decimals since I'm going to need 451, 4162. I suspect I'll need that later, so I may as well write them down for when I need them. Calc 0 for the other one. And again, this is not at all cheating. Like AP Test knows you can do this. They expect you to do this. Left bound, right bound, guess. 3.215, 2504. Part C. When is the particle at rest? Okay, that's when the particle is at rest. When is it moving to the right, to the left? Justify your answers. Well, that would be where v is greater than 0 or v is less than 0. So I'm going to do a number line with 1.451 and 3.215 on it. And normally, I would pick a test point, 1 and 2 and 4. Actually, we already did 2. V of 2 was positive. But I don't even have to do that because I can look at my graph and see that it's positive in the middle and it's negative at the ends. And that's okay to do because you have, if it's a calculator question, they know you can do that and they're okay with that. So it's moving left. Or do we go left and right? Yeah, left and right. Moving right when V is positive, 1.451 to 3.215. And the reason is because V is greater than 0. And that's all we need to say for a reason. So, again, with justifying, make sure your justifying is, really you'd like it to be as brief as possible while still maintaining accuracy. Like there's still some people who, when it says justify, they want to write a paragraph explaining the history of calculus. Like, no, that's not what I'm talking about. How do you know that? Why do you know that? And the statement may be as simple as V is greater than 0, and we're good. Moving left from 0 to 1.451 and 3.215 out to infinity, because I don't think this problem put an end on our time. It just says t is greater than 0, so we can go out as far as we want. And that's where v is less than 0. Questions so far?
Is there like a reason why it's 0 to 1.451 instead of negative infinity?
Good question. Why do we start at 0 here? The question did say that equation holds for, if you look all the way back, for t is greater than or equal to 0. So it told us that we were starting time at 0. We weren't allowed to go backwards. So that's a good question. In general, if it wasn't a motion equation, yeah, you would go all the way back to negative infinity. But since it restricted us, we'll stop at 0. Part D, find the displacement. Part E, find the distance. Well, displacement, that's just where we landed compared to where we started. So displacement during the first 2 seconds would be s of 2 minus s of 0. So displacement is easy. Distance is where we have to be careful. S of 2. Let's see, I think I have s in here as well. Yep. So there's the graph of displacement. I could just plug in 2, but since I typed it into the calculator, I'm going to let the calculator plug in 2. This will be especially helpful when I want to plug in more and more values. Then I don't have to type in the full equation. I mean, I type it in once, and the calculator can do all the calculations. So s of 2 is 0. S of 0, I can plug in 0 on my own. Or I guess I could let the calculator do it. Either way, s of 0 is 8. So 0 minus 8. So the displacement is negative 8 meters. So in the first 2 seconds, or 8 meters to the left of wherever we started. Part E, we want total distance, which means we probably need to do a motion diagram.
Couldn't you just do a motion diagram and bypass all that math?
I mean, I could do a motion diagram in order to get part D. Is that what you mean?
Just, and also part C.
I can't do a motion diagram without these 2 times.
I meant like for the right and left.
Yeah, you're right. The motion diagram would help me answer moving right or moving left. Absolutely. Yes. Yeah. So whichever one you did first would help you do the other one, or you could avoid doing one of them. Although, I guess you can't avoid doing a motion diagram because we've got to get those measurements for how far we went. So this is a kind of a position number line. And we need to know the position at 0, so where we start. And we need to have those key points on there. 1.451, 3.215. Although the distance just says from 0 to 2. So I don't really need the motion diagram to go to 3 if I'm stopping at 2. But if I want the full thing, I would need to include the 3.2 value. So S of 0 we already know is 8. S of 2 is 0. S of 1.451, I'll let the calculator handle that. So I'll plug in 1.451, but rather than me cubing it, squaring it, just let the calculator do all that stuff. Negative 0.631. And while we're here, 3.215. 2.112. Or 113, I guess, round correctly. So we need to translate these points into a picture. So we're going to start at 8. So there's our starting point. T equals 0. When t is 1.451, we're back here. Let's see, we'll say that's 0. But we go past 0 to negative 0.6 at t equals 1.451. Again, this is a pain just because all the decimals floating around. Some people put arrows on here to kind of help remind them that which way we're going. So we're moving left from time 0 to 1.45. That matches our velocity number line from up here, or what we said right here, 0 to 1.45. We're moving left. I guess, as always with math stuff, the more you do about a problem, the more it starts to fit together. At time 2, we are back to 0. And I guess for this problem, we could stop there because it wanted the distance from 0 to 2. Now, if we wanted to keep going, we would see that it comes over some more and then backs up again. But for our question, we just want total distance from 0 to 2. So let's see. That distance is 8.631. Right, that was the first distance we traveled. And then plus, let's see, maybe this will help. So that's 8.631. And then that last little bit is another 0.631 because we get back to 0. Maybe that helps see which way we're going here. So 9.262 for our total distance traveled. All right. Question F, are D and E the same? No. Explain. I don't know what they want for an explanation other than distance and displacement aren't the same thing, so I'm not worried about that explanation. And then lastly, for this one, speeding up and slowing down, I'm going to back up and do the acceleration picture right above the velocity picture because that's the two that I need to see where they have the same sign. And it's also convenient that acceleration is right there. So I can set acceleration equal to 0. So at 2.3, my acceleration changes. Something's going on there. If I plug in something less than 2.3, if I plug in 0 or 1 or even 2, I get a negative number. Nope, I get a positive number. If I plug in something more than 2, if I plug in 3 or 4 or 5, then I get a negative number. So now I'm kind of looking for where are they the same, where are they different. And some people could do this without doing any more drawing on here. You could just look and see, well, up to 1.451, they're different. But if you draw that line, sometimes you lose who's positive. So that's why I like to, I don't know, I guess it's overkill. But it helps me visualize what's going on where when I do that. I think it's easier to see now. So we're slowing down when they don't match. So from 0 to 1.451. We're speeding up where they do match. So where they have the same sign. So that would be 1.451 to 2.333. Just again annoying with the decimals on this one. Then the next little piece, they are different signs. So we're slowing down. From 2.333 to 3.215. And then from there on, the signs match, so we're speeding up after that. Although speeding up in the negative direction, so speeding up backwards. All right, that's a lot of stuff going on in that problem.